In this video lesson, we're going to learn about hydrocarbons, and we'll learn about the differences between alkanes, alkenes, and alkynes, and we'll learn how to name them, draw them, and then identify branched alkenes, alkanes, and alkynes. So hydrocarbons are molecules containing carbon and hydrogen only. That's where the name comes from, hydro for hydrogen and carbon. Carbon makes up the structure or the backbone of the molecule, as you can see here. And then hydrogen atoms fill up the empty bonding spaces. In alkanes, all the carbon atoms are joined by single bonds, like this one here. So this would be ethane. Alkenes have at least one double bond in the carbon chain, so this one would be ethene. And then alkynes have at least one triple bond in the carbon chain. So this is an example of ethine. So to help us name hydrocarbons, we need to understand the numerical prefixes. So I've included this table that will be a helpful resource. So we have 1, the prefix is meth. 2, the prefix is eth. 3 is prop. 4 is bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. And 10 is dec. So these will come in handy throughout our entire organic chemistry unit because we will be naming these hydrocarbons. So now we'll talk about the properties of alkanes. Alkanes make good fuels, but otherwise they're relatively unreactive. And this is because the carbon and hydrogen bonds are nonpolar due to the low electronegativity between carbon and hydrogen. It's about 0.4. So that means they aren't likely to react with things. And the carbon and carbon-hydrogen bonds are strong covalent bonds, making the molecule stable. So they're unlikely to have those bonds break and reform with something else. So now we'll learn how to name unbranched alkanes. So these are alkanes that are just in a straight line. The first thing you do is you count the carbon atoms in the chain, and then you pick the correct prefix, and then you add ane to the end. So I've drawn the same molecule two different ways. This is the branched out format, and then this is the condensed format. So the branched out one shows you exactly where the hydrogens and carbons are bonded to, and this one just tells you the CH3, CH2, CH3. It's the same thing as this one. So let's take a look here. So we've got 3 carbons, and they're all single bonds, so we know it's an alkane. So we have to look up the prefix. The prefix for carbon is prop. And then we add ane to the end. So it's propane. So now if we were asked to draw an alkane, you would first create the carbon backbone. So you draw your carbons, and then you would add hydrogen atoms to fill the empty bonding pairs. So in this example, we have ethane. So eth is for 2. So there's 2 carbons. And then we'll remember carbons can make 4 bonds. So we add up the remaining bonding pairs here, like so. And then we draw hydrogen. Like so. Now you could draw it in the more condensed format, so that would be CH3, CH3. So the end carbons will always have 3 hydrogens, and all the ones found in the middle of the chain would be CH2 if we're talking about an alkane. So let's do some practice now. So I've recorded 7 different examples. Some of them we'll have to draw, some of them we'll have to name. So number 1, we count the number of carbons. So there's 1, 2, 3, 4, 5. The prefix for 5 is pent. So this is pentane. The next one, there's just 1, 2. This is actually the one we drew, so that's ethane. The next one is 1, 2, 3, 4, 5, 6. So that's hexane. The fourth one, methane, meth is for 1 carbon, so we'll draw the carbon and then the 4 hydrogens. So you could draw it like that, or you could just record CH4. Because there's nothing else carbon's bonded to, every space is filled up with hydrogen, all 4 of its bonding pairs. And then butane, that's 4. So you could draw it like this, CH3 for the end carbon, CH2, CH2, and then CH3 to end it off. Nonane is 9, so I'm going to do it in the condensed form too. So CH3, so remember it's 9, CH2, 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 I've lost count, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's nonane. And then pentane we'll draw branched out. So pentane is 5. So we've got C, there's 5. And then we can draw our empty spaces and put hydrogens in. Like so. And that's pentane. Now naming branched alkanes adds a little bit more of a challenge. So you have to look and see which chain of carbon is the longest. And the chain doesn't have to be straight. So you have to make sure you look at all the different branches and try to find out the longest chain possible. You'll number the parent chain starting with the end nearest the first branch. Then you name the branch. It's named as if the piece were a separate molecule, except instead of putting ane at the end, you'll put YL as the suffix. And then you number the position of the branch in the name of the molecule by placing the number in front of the branch name. So for this one, we need to take a look. So we've got, if we count here, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. It actually, either way, would be the same molecule. So the first thing we have to do is number the carbon atoms in the parent chain. So we pick this 1, 2, 3, 4, 5. The branch is right here. So the branch has 1 carbon in it and it's on number 2. So the way we number this is it's 2-methyl, and then there's 5 carbons, so pentane. And that's how you name a branched hydrocarbon. Now drawing branched alkanes, you draw the parent chain first, and then you add the branch chains, or chain, and you fill in the empty bonding spaces with hydrogen atoms after you've drawn in the branches. So in this example, we're being asked to draw 2-methylbutane. So the first thing we do is the parent chain. So 1, 2, 3, 4, because butane is 4. And then 2 means it's on the second carbon. So not the very first one, the second one. So, and it's methyl, so CH3. And now we'll fill in the empty bonding pairs. So there'll be 1 on each of those. There'll be 1 there, there, and there. So we throw in our hydrogens right here, here, and on the last carbon. Now if you wanted to, you could draw that collapsed form as well. So you would do like CH3, CH with a CH3 coming off the top, and then CH2 and CH3. It's really up to you how you draw it. Either way is correct. So now we'll practice with some drawing. So the first one, we were told to draw 4-methyldecane. So decane is 10 carbons. So we'll start drawing those out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the 4th carbon in 1, 2, 3, 4, there's a methyl. So So we'll do that, like so. And then we'll fill in the empty spaces. So you'll see here on the carbon number 4, because there's a group coming off the top, it's not going to be CH2, it's going to be CH. So now we'll put in these hydrogens. There's some more. We're getting close to the end. So you can see this format is a little tedious sometimes. So the next one we're going to practice writing in the collapse form. So in our second example, we're being asked to draw 2,2-dimethylpentane. So we'll draw 5 carbons, like so. And on the second one, there are 2 methyls. So we're going to do CH3 coming off the top, CH3 coming off the bottom, and you'll see that there's no space for any other bonding pairs. The end carbons always have CH3 unless, there's some other functional group coming off. And then the ones in the middle, except for that one that has the branches coming off, will be CH2. And I'm just going to fix that up a little bit, move it closer, and that is how you draw 2,2-dimethylpentane. So we're going to do some practice with some trickier ones. So if you look at this first one, if you count the chain this way, 1, 2, 3, 4, 5, it looks like we have 5. But if you take a look at the branch up here, we've got 1, 2, 3, 4, 5, 6. So it's actually going to be, this is the chain, and the closest branch would be on the third carbon. We'll number them just to be sure. So this is carbon 1, 2, 3, 4, 5, 6, and then this is going to be our branch here. So it's on carbon 3, and it's 1 carbon in the branch, so it's going to be 3-methyl, and then 6 is hexane. So for the second one, it's also a bending parent chain. So if you take a look, the longest chain would be found here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you take a look at numbering, we have to find out which one, on which end does the first branch happen. So on carbon 3, there'd be a branch here. But if you look here, if we count from this end, on carbon 3, there's actually 2 branches. So 2 branches are more important than just 1, so we're going to name from that end. So we'll number them first so we don't get mixed up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we actually have 3 of the same group coming off. So we have 1 here, a 1 carbon branch here, a 1 carbon branch here, and a 1 carbon branch here. So to name this one, we're actually going to name the position. So it's 3, 3, 7. We need to put how many of them there are. Trimethyl, because it's 1 carbon, and then it's a 9 carbon chain, so nonane. So that's how you would name a multiple branch hydrocarbon. So now we're going to take some time to talk about alkenes and alkynes. Alkenes have a double bond between one or more of the carbons in the chain, and an alkyne has a triple bond or more in the carbon chain. So how we name alkenes and alkynes. The first thing you do is you count the number of carbons in the parent chain and you name the parent chain. Then you number the carbons, starting at the end that's nearest the double or the triple bond, or the first double or triple bond. Then you number the position of the triple bond, or the double bond. So just know that alkenes have double bonds and end in -ene, and alkynes have triple bonds and end in -ine. So now we're going to practice with this and try drawing and naming some alkenes and alkynes. So in this example, we have a double bond. And in this case, the double bond is found closer to the right-hand side of the molecule, so we need to start numbering from that end. So this is carbon 1, carbon 2, 3, 4, 5. So it's going to be pentene. And we see that the double bond is between carbon 2 and 3. So we say that it's 2-pentene. In our next example, we have a triple bond. So this is going to be an alkyne. And we see the triple bond starts towards the left-hand side. So we'll number from there. So this is carbon 1, 2, 3, 4, 5. So it is going to be 2, and it's 5 again. So pent-ine, because it's a triple bond. So in this example, we're being asked to draw 3-heptine. So we're going to draw that out. So we're going to draw the parent chain first. So 1, 2, 3, 4, 5, 6, 7. And it's saying that between carbon 3 and 4, there is a triple bond. So that would be right here. So I'll add in a triple bond. And now I'll fill in the remaining hydrogens. Remember, on a triple bond, you won't have any hydrogens. So we're just going to skip over those two because we've used up all the bonds and the electrons between the carbon atoms to make that triple bond. So now we'll fill in the hydrogens like so. And there you have 3-heptine. So now we're going to practice drawing some and naming some of these alkenes and alkynes. So the first one, we're being asked to draw 1-pentene. So again, I always like to draw the parent chain first. So there's 5 carbons for the pent. And then on it says it's 1-pentene. Ene means there's a double bond. So, and it's on carbon number 1, so between number 1 and number 2. So remember, when you put that extra bond in, you have fewer spots to put hydrogen. So it's no longer saturated with hydrogen. So there'll be 2 hydrogens here, only 1 here. And you can draw it on the top or the bottom, it doesn't matter. And then we fill the rest in like so. And there you have 1-pentene. The next one, we're being asked, it says 2-methylhex-3-ene. So that means that there is a double bond on the 3rd carbon in a 6-carbon chain. So we're going to draw that. So 1, 2, 3, 4, 5, 6. And then on carbon 3, so that's carbon between carbon 1 and 2, between carbon 2 and 3. So there it is. And then on the 2nd carbon, there's a methyl. So we'll put that one in. And now we'll fill the rest of the bonds up with hydrogen. So remember, you could only have 1 hydrogen left over on those double bonds because the double bond takes away one of the spots for hydrogen to bind. So there we go. That's 2-methylhex-3-ene. Okay, our next one, we've got 1, 2, 3 carbons. It's a triple bond, and the triple bond is between carbon 1 and 2. But if you do it the other way, it would be between carbon 1 and 2. So we don't need to put the position of the triple bond. So this is just going to be propyne. And that's it. The 4th one here, we have 1, 2, 3, 4 carbons. And we have, there is a triple bond after carbon 2. So this is going to be 2-butyne. And there were no other groups. So that is how you name and draw alkenes and alkynes.